Impedance matching is actually a concept that involves the design, the source, the load, or transmission line of a system so that the impedance of one part actually matches the impedance of the others. When this actually happens, the goal is to maximize maximum transfer of power or minimize signal reflection in the system. Okay, let me explain by this diagram here. Let's say this is the schematic for the mobile phone. We have the transmitter for the mobile phone. We have the antenna, and how the antenna actually connected to the transmitter will be via this cable here. So from here, you actually can see that there are actually three impedance. The first one will be the impedance of the antenna. The second one will be the characteristics impedance of the coaxial cable or any cable. The last one will be the transmitter, okay, impedance when we actually look into this direction. This diagram you can actually relate to this diagram here. This will be the antenna, this will be the cable, and this part here will be the transmitter. So when we actually do a match, which means that 100% of the power will be delivered to the antenna. Okay, just imagine this. This is a signal that is actually propagate along the cable. So when they actually reach the load, let's say there will be some reflected power, which means that not all the power will be transmitted to the antenna. This is undesired, and therefore, because of this, we do not have maximum power transfer because there will be some reflection signal. So as to ensure maximum power transfer, okay, we need to do impedance matching. When we actually do this impedance matching, we actually transmit all the signal from the transmission line all the way to the load, and then basically 100% will be delivered to the antenna. How can we actually do impedance matching? There are actually two simple scenarios. One is we call the match impedance. The other one is the mismatch impedance. Under the condition of match impedance, the load ZL must be equal to ZS and must be equal to Z0, as you can see from here. When this occurs, which means that all the power will be transmitted from the source all the way to the load. Okay, which means that from this part, all the transmit power will be sent to the antenna. And then we can declare that we actually has maximum power transfer. When this occur, we need to ensure that there won't be any reflection. And when there is no reflection, the reflection coefficient will be equal to 0. As for mismatch impedance, okay, either one of these actually occur, we have the mismatch impedance. When ZL not equals to ZS or ZL not equals to Z0, either one, we actually will have some signal reflection. As I illustrated early on, when we actually has reflection, we could not 100% deliver the power to the load, and therefore this actually led to VSWR. Okay, so basically once we have VSWR, which means that not 100% of the power transmit over. And because of this, we actually has a reduced power transfer coefficient. Okay, so basically not 100% of the power actually transmit. The reflection coefficient will be non-zero. 0 means that 100% transmit. 1 means that 100% actually reflect. And with this, I'd like to end my discussion. If you can, please see the playlist under the description.